Hey guys, welcome back. Today is day 61 and we're going to learn how to simplify radicals. So the symbol right here is called a radical. Okay, the actual symbol is called a radical. The little x that we can see here sometimes is called the index. Okay, and the number that's underneath, okay, the radical symbol is called the radicand. The index tells you what you are taking, whether it's the third root, the fourth root, or the fifth root. If there's no index, which we see most of the time, okay, we assume that is the square root. Okay, so for purposes of discussion, although we know that the square root of 25 is equal to plus or minus 5, okay, because we know it can be a negative, because a negative times a negative is also a positive, okay, when we're simplifying radicals, we're only going to deal with the principal square root. So the principal square root is the positive, okay, is the positive. All right, so the principal one is positive. We're not going to worry about negatives for simplifying, okay, so only the principal square root. All right, so we know that if we have an input of 1, x is 1. If we square it, we get 1 because 1 times 1 is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then we've got 25. 6 squared is 36. 49, 64, 81, and 100. Hopefully you know up to 10. Okay? If not, 11 and 12. So 11 squared is 121, and 12 squared is 144. Okay, you may not know the other ones, but 13 squared is 169. Then we've got 14 squared is 196. 15 would be 225. 16 would be 256. 17 would be 289. 18 would be 324. 19 squared would be 361. And 20 squared would be 400. Okay, so there's a list of the perfect squares up to 400. If you take the square root of a perfect square, you get a whole number. That's why it's perfect, okay? So if I take the square root of 1, I get 1. 4, I get 2. 9, I get 3. 16, 25, 36. 49 is 7. 64 is 8. 81 is 9. 100 is 10. 121 is 11. And 144 is 12. Okay? So take a minute. All right, and try to do the next 10. Pause the video and then come back, see if you got the right answers. Again, we're only dealing with the positive answers. So I'll put the answers here and see if you get them correct. See how fast you can do them. There we go. All right, so hopefully you did a good job. All right. Now to simplify a radical, we have two methods, okay? The first method is we're going to take what's under the radic. We're going to take the radicand and we're going to split it. We're going to split out the perfect square factor, okay? So if you recognize, for instance, A up here is radical 40. Now I know if I think of my perfect square factors, again, I'm going to list them here. 16, 25, 36. I'm going to do some of them. 49, okay, 7, 8, 64. Okay, so these are perfect square factors. And I look at the number 40, so I know it's going to be less than 40. And I look at all of these numbers here, 36, 25, 16, 9. Which ones are factors? Okay, well, only 4 is a factor. So I can actually represent 40 as radical 4 times radical 10. Okay, so now I can take the square root of 4, and that's a perfect square, so I end up with 2 radical 10. So that would be radical 40 and simplified, okay, when I simplify it. If I take B, all right, so we're looking at B is radical 27. So my largest perfect square factor, so 27, it's not going to be 16, but it is going to be 9, so I could say 9 and 3. The square root of 9 would be 3. So we'd end up with 3 radical 3. That would be it in simplest radical form. Now C, we have 3 radical 32. Now this is interesting. The 3 is on the outside, so we're going to multiply that later. So we want to not forget about that. So I like to draw a circle and then a little arrow there so I don't forget. Okay, but I'm looking at just the radicand, so what's underneath. The largest perfect square factor would actually be 16. So I could have 16 and 2. That's 3 times it, okay? So I'm not going to forget about that 3. The square root of 16 is going to be 4, and then radical 2, okay? Now I multiply 3 times the 4, and I get 12, so I'd have 12 radical 2, okay? So that's spelled out in your 3 examples there. All right, the second method, and we have the same examples, I just want to show you you're going to get the same answer, is to make a factorization tree. All right, and we're going to circle all of the prime factors. If you remember, a prime number only has 2 factors, one in itself. So it doesn't matter how we start out, but when we start splitting apart the factors, so I'll say 40, maybe it's 4 and 10. Okay, and 4 would be 2 and 2. 2 and 2 to get 4, and they're both prime, so I'm going to be sure to circle them. And 10, I can multiply 5 times 2. Okay, so how this works now is I look at the index, and since in this case my index is 2 because there's nothing there, that means that I'm looking for my doubles or my pairs. Okay, so notice I have a pair of 2's. So I can pull that outside of the radical symbol and put a 2. Okay, because each pair I write it just once. Okay, because really the square root of 4 is 2. And then what I have left over, the 5 times 2 goes back inside, and we end up with 2 radical 10. Okay, and we ended up with the same answer the other way as well. All right, if I look at B, again my index is 2. All right, I'm going to start out and factor it. And I'm going to do 3, whoops, I've got 3 and I've got 9. Whoops, I forgot to write the 9 down. Okay, so I've got 3 and 9, and then with 9 I can have 3 and 3. All right, since my index is 2, I'm just looking for my pairs. Okay, so I've got 3 and 3, that comes outside, and then what's left over is just a 3. So that would be my answer. Okay, now the last one, I don't want to forget about that 3, bringing that down. Okay, I'm going to take the 32, and maybe I'll say 2 times 16, then 8 times 2, 4 times 2, and 2 times 2. Running out of space here. So all these 2's get circled. Okay. Again, my index is 2, so I'm looking for my pairs. So in this case, I've got 2 pair of 2's. So I'm going to multiply it twice. There's my first pair, there's my second. And what's left over is just that other 2. Okay, so my final answer here would be 12 radical 2. Okay. All right, so let's go ahead and try some of them. All right, so if you would like to pause the video and try some yourself, you're welcome to do that, but we're just going to go ahead. I'm going to start doing prime factorization. I've got 4 and 5, and you could have 10 and 2. You could have different numbers. You're going to end up with the same prime factors at the end. Okay, so in this case, my index is 2, so I'm looking for my pairs. So 2 comes outside, and what's left inside would just be a 5. So it's actually kind of far apart, but that would be 2 radical 5. Okay, 90, maybe 9 and 10 I start with. Okay, and this is where I see most of the mistakes, are people just trying to get the right factors. Okay, 5 and 2, they're both prime. So again, my index is 2, and you may want to write that each time, index equals 2, so you don't forget what you're looking for, either doubles or triples. Okay, in this case, we're looking for doubles. So we got one set of double 3's on the outside, and on the inside, we have 5 and 2 left. So it's 3 radical 10. Okay, so number 3, the index is actually 3. Okay, that's where that little 3 comes from. So we're going to start doing the prime factorization. I'll say 102. 100, I can do 10 and 10. And with 10, I can do 5 and 2 for both of them. Notice I always circle my prime factors. That makes it easier for it to stand out. So since my index is 3 now, I'm looking for my triples. Okay, so I've only got 1, 2, 3 triple 2's, so that comes outside the radical. And then what's left over are 2 5's. So 5 times 5. So this becomes 2 radical 25. Okay, so again, look at that index. If I look at number 4, again, my index is 3. Taking this step just helps kind of get your brain thinking about whether you're looking for the doubles or the triples. Okay, so 432, you could start to maybe divide by 2 or 4, because I know 32 is divisible by 4. So this is divisible by 4, so it actually would be 4 and 108. And then 4 is 2 times 2. And then 108, maybe I'll say 12 times 9. And 12, I've got 4 times 3. And 3 times 3 for 9. So we got these circled because they're prime. But my 4, I can continue on and get 2 times 2. Wow. Okay, so now I'm looking for my triples. So I got 1, 2, 3. Okay, triple 3s. And then I have triple 2s. Okay, so then what's left over is going to be on the inside. We're not going to forget about that little 3. That's really important. Okay, and that reminds me, did I forget about that in my last answer? I did. I forgot it. It should be 2 cube root of 25. Oof. Be careful with that. Okay, so for this one, we've got cube root. All right, and what's left over is going to be just that 2. That's the only thing not crossed out. So when I finish, I've got 6 cube root of 2. Okay. Number 5, we're not going to forget to multiply by that negative 3 at the end, so we're going to pull that down. 125, maybe I'll do 5 and 25. Think of quarters. 5 quarters makes $1.25. 5 is prime, and we got 5 and 5. All right, so with this one, our index is 2, so we're looking for our doubles. Okay, so on the outside, we've got 1 pair of 5s. And then on the inside, we've got 5 left over. Okay, so when we simplify this, negative 3 times 5 is negative 15, and it's radical 5. All right, so with number 6, again, this is a cube root, so our index is 3. All right, we're not going to forget about that 7 to multiply at the end. We'll take the 192 and we're going to split that, let's see, how about 4 and 48? All right, 4 we can split to 2 and 2. 48, maybe 6 and 8. 6 we keep going, 3 and 2. And 8 would be 4 and 2. And with 4 we can keep going. So we got the tree there. All right, so we're looking for our triples. Okay, so we've got 1, 2, 3 triple 2s. So we're going to say 7 times 2. And then let's see, we got another set of 2s. 1, 2, 3. Okay, so that's going to be on the outside. And it's going to be what's left over is the cube root of just that 3 is left over. Now we're going to multiply, and we get 7 times 2 is 14 times 2 is 28. So it's 28 times the cube root of 3. Okay, so that's how we do it with numbers. All right, now we're moving on, and if the radical contains variables, we write out the variables and we find either the pairs for 2 or the triples for 3. So the coefficient piece works the same, okay? 72, maybe that's 9 and 8. We've got 3 and 3 for 9. 4 and 2 for 8. Okay, so there's our prime factorization. Because we're looking for our triples, we're going to get triple 2s, so we're going to pull that 2 out. We're going to leave some space, not going to forget to make the cube root symbol, and we're leaving some space for the variables here. So what's left over, what goes under the radical sign would be the 3 times 3, because they were left over. All right, so with the variables, if I have x to the 4th, okay, I have 4 x's. I'm looking for how many triples I have. I have 1 set of triples, so there's x to the 1st power with 1 x left over. Now with y to the 3rd, I just have 1 set of triples with nothing left over, so nothing goes in. So when I multiply, I end up with 2xy cube root, and it's going to be 9x. Okay, so there's our answer there. All right, for number 8, I'm not going to forget about that 6. That's going to come down. Okay, and we're going to take 450, and let's do 45 and 10. We've got 9 and 5, and 3 and 3. So there's our primes on that side, and then we have a 5 and a 2. Okay, this one our index is 2. I don't keep doing that, but index is 2, so we're looking for our doubles. Okay, so for the number piece, all right, we've got double 3s. So that goes on the outside, and then we've got double 5s. There we go. And then what's left over on the inside would just be a 2. Okay. For our variables, we've got x squared. so we only have one set of doubles with the x, and we can't do any doubles with the y, so just one y would go inside. So when we multiply 6 times 15, we get 90x radical 2y. All right, number 9, our cube root is the index is 3. All right, we're going to not forget about this negative 2. Bring it all the way down. Okay, and let's leave some space. Maybe I'm going to put that cube root in right now so I don't forget about it. All right, 120, I'm going to do 12 and 10. 12, I'm going to do maybe 4 and 3. And then 2 and 2. And 10, of course, is 5 and 2. Okay, so with the number of pieces, again, we're looking for our 3s, triples, 1, 2, 3. So we've got 2. Okay, and then on the inside, we have 3 times 5. What's left over? All right, our variable is x to the 5th. 1, 2, 3, 4, 5. So we divide by 3 and we get 1, x to the 1st, with 2 left over. So we're going to show the 2 as x squared. That's how it's going to go in there. So our final answer would be negative 4x cube root of 15x squared. Okay, so I highly recommend pausing the video and trying maybe the next 3. Okay, so if we try 10 and then play it again, all right, we've got 7 times 7. They're both prime. Not going to forget about our 11. Okay, so since we're looking for our indexes 2, we're looking for our doubles. We're going to get just 11 times 7. Okay, the variable is x to the 6th, so an easier way to do this than drawing out 6 x's would you just think, well, what's 6 divided by 2? It's 3, so it's just going to be to the 3rd. Notice with this example, there's nothing that goes inside the radical sign. So in that case, our final answer is just going to be 77 x to the 3rd, and we don't even write the radical sign symbol. All right. Number 11, we don't want to forget about the negative 3. That comes down. All right, our index is 2. So with 18, we've got maybe 6 times 3 and 2 times 3. Okay, we're looking for our pair. So pair of 3s goes on the outside. Oops, we're all the way down here. Okay, and then left inside the radical symbol would just be a 2. Now our variables, okay, a to the 5th. All right, so we've got 5 a's. We're grouping them in groups of 2. There's 2 of them, so a is going to be the second power, and what's left over is just an a. And then our b's, we have 2 b's, so that's just going to be 1 b on the outside. So our final answer here would be negative 9 a squared b radical 2a. All right, and now our final one. Okay, we're not going to forget about the 5. We're going to bring it down. All right, our index is 3 here. So I'm going to do 7 times 8. Okay, I've got 4 times 2. Okay, so now I'm looking for my triples. So I've got 1, 2, 3 triple 2s. What's going to go on the inside would be the 7. Okay, so with the variables now, we've got x to the 8th, so we can either write out 3, 4, 5, 6, 7, 8, and do our triples. So we got 1, 2, or we could think 8 divided by 3 is 2, so it's going to be x squared with a remainder of 2. So what's going to go on the inside would be x squared like that. Okay, and we can't forget it's the cube root. So our final answer would be 10 x squared cube root of 7x squared. And that's it. Highly recommend you guys try the exit ticket. That's on Desmos, and that's it. So thank you for joining us. Bye.